Good afternoon and welcome to your next session this afternoon. So we are now on chapter 11 in our class IT 320. So we are still on middleware on chapter 11, and our topic for this afternoon is about message-oriented middleware or MOM. So before that, let's discuss our objectives. Number one, discuss the importance of message-oriented middleware in systems integration architecture. Value the importance of message-oriented middleware in systems integration architecture. And number three, understand the basic concepts of message-oriented middleware in systems integration architecture. So when you speak about MOM or message-oriented middleware, this is a software or hardware infrastructure support sending and receiving messages between distributed systems. So as you can see on figure 29, this is an example of a messaging integrator. So we have the client API, the sending of the message, the messaging provider or to form the destination, and the receiver and the client API. So message-oriented middleware allows publication or application modules to be distributed over heterogeneous platforms and reduces the complexity of developing applications that span multiple operating systems and network protocols. So the middleware creates a distributed communication layer that insulates the application developer from the details of the various operating system and network interfaces. So for API that extends across diverse platforms and networks are typically provided by MOM. And the example of the middleware layer allows software components such as the application, enterprise, Java, Bean, servlets, and other components that have been developed independently and run on different networks per platform to interact with one another. So the application distributed on different network modes use the application interface to communicate. And in addition, by providing the administrative interface, this new system or new virtual system of interconnected applications can be made reliable and secure. So MOM provides software elements that reside in all communicating components of the client-server architecture, and it usually typically supports asynchronous calls between the client and the server application. So MOM reduces the involvement of application developers with the complexity of the master-slave nature of the client-server mechanism. So for middleware categories, we have the first is the remote procedure call or the RPC-based middleware. It is where the remote procedures call or RPC is a substantial procedure for putting up a valuable middleware using remote elements. So remote elements provides applications that interacted with different categories such as the client and the server technology. Now in remote procedure, all you have to do is to recall a kind of infrastructure or category or library in programming, for example, and then recall it and use it. For Object Request Broker or ORB based middleware, this refers to the category wherein you'll be able to understand the basic concepts for object requests and the brokerage of the programming languages. Okay, this enables you to communicate within the object matter and specify the conditions which procure the basic necessities for an object to function. So you all know in our inheritance class in programming that the object are preceded by your classes. So whatever the nature or the attribute of an object, basically it results to the inheritance of the subjects to the call function. And the third one is the message-oriented middleware or the MOM, which is our topic for this afternoon. And these all models make it possible for one software component to affect the behavior of another component over a network. So they are different in such a way that in the first, the remote procedure call, and number two, the object request broker create systems of tightly coupled components. Whereas ang MOM-based naman na system allows for a loose coupling of components. So whether you use the RPC or ORB, then you can call one procedure from the other. So it must wait for the call procedure to return before it can do anything else. So just like your messaging in pinging the network. So if you're pinging it in the network, when you type ping into your C prompt component and be able to specify the IP address, then you'll be able to have the response of the network. Okay. Let's go to the advantages of MOM, or the messaging oriented middleware. So the central reasons for using a message-based communications protocol includes its ability to store, to route, or to transform messages while conveying them from the sender to receivers. Now, I think you have a background of this in your datacom subject. You'll be able to discuss the components of your network, no? So, or the types of the network that you can possibly implement on a local area network, for example. Okay, so the first example here, or the conveying message here that you can see, is asynchronicity or asynchronous production. So using MOM system, a client makes an API call to send a message to the destination managed by the provider. If you will notice, asynchronicity is the most common of them, no? So if you're using a messenger, or the Facebook Messenger for that matter, I think that is a very good example of asynchronicity. So once it has sent the message, the client can continue to do other work, no? With confidence that the provider retains the message until the receiving client retrieves it. The message-based model, coupled with the mediation of the provider, makes it possible to create a system of loosely coupled components. The second one is routing. And routing has many message-oriented middleware implementations depending on the message queues system. So some of these implementations permit routing logic to be provided with the messaging layer itself, while the others depend on the client application to provide routing information or to allow for the mix of both of paradigms. So some implementations make use of the broadcast or multicast distribution paradigms. Now, in routing naman, guys, routing is just like a traffic light wherein you'll be able to control the flow of information from one direction to another. So in routing, you'll be able to direct, like for example, on a BCQ. BCQ means ang puno doon nga queue sa isa ka system or sa isa ka network, naga-bottleneck na siya. So as you can see on the bottleneck, nagagutok na yan yung information, and sometimes you feel if you're having a difficult using your internet and there's a bottleneck there, then you cannot find any solutions about that. So that is called routing. When you are going to route your information for the server or to the you direct the traffic from one channel to another. So in the network you have channels, no? Channel 31. Aton nga internet ng most common network sa dang interfacing, especially in Globe and in Smart, is channel 11. Now, channel 11 is a different matter for different service provider. However, when you speak about channel 11, this is the most common or the first basic channel that you can connect to. And mind you, your router or your modems is directed to channel 11 all the time. If channel 11 in one way or another has a field network capacity, and it provides maximum tolerance to the population or to the users or to the end users. Now what will happen is, in routing, you'll be able to reroute yourself or the network will reroute you to another channel. Say for example, channel 21. So kay puno nun ang channel 11, then you'll be directed to channel 21. So you can see there, or you can feel the conditions of the traffic flow for the network na medyo mag-an na siya. So at that point in time, you'll be able to use your internet freely than the previous channel, which is channel 11. So the third one is transformation. And in transformation, this is the message-based middleware system that the message received at the destination need not be identical to the message originally sent. So like for in the MAM system naman, there's a built-in intelligence can transform messages and route to match the requirement for the sender and the recipient. However, in the conjunction with the routing and broadcast multicast facilities, one application can send its own native format and two or more other applications that each receive a copy of messages in their own native format. So for your information lang, when we speak about native format, this is the raw format that any file could be produced or to be followed. So like for example, what we're having right now in our lecture is I have a raw native file in WAV file. Then that WAV file must be uploaded in the internet and converted into MP4 on YouTube so that it can be converted to the most common file network, which is on video, and it is MP4. So that is an example of a transformation. And many modern MAM systems provide sophisticated message transformation. Sa messaging naman ni siya guys, which allow programmers to specify transformation rules applicable to simple GUI drag and drop operation. If there's an advantage of MAM, there's also disadvantages. And these disadvantages talks about some specifically not so good things about MAM. So the first one is the primary disadvantage is the middleware systems requires extra component in the architecture. So what are these? These are a transfer agent, which is the broker. So as we have other systems, adding another component can lead to deduction of performance and reliability. So take note about that. So there's a decrease in performance and reliability, and sometimes this can affect your processes. And the second one is that communications have an intrinsically synchronous aspect, with the sender specifically wanting to wait for a reply to a message before continuing. So what does it result? It results in delay. So because message-based communications inherently functions asynchronously most of the time, so take note, it may not be fit well in such situation. So whatever happens is that it takes a long time of the queue for the messages to appear. And what does MAM do? It waits for the message to appear. And it's not healthy. Because if you wait for it, then you will spend time in waiting for the queue of messages. So the third one is that synchronous messaging. Then the calling function does not return the function that is being put into the task. So it is loosely coupled with a synchronous system and calling clients that can continue the workload upon the recipient until the resources needed to handle this work are depleted and called components fail. So for this one, of course, these conditions can be minimized by avoiding the monitored performance and adjust the message flow. But if you cannot manage this, guys, I think your system components will fail. And this also result in the degradation of the quality of the call or messages that you receive. So I think the remedy for that is to reset the functionalities. So it's very basic, no? When you are going to, especially again if your phone is older, you may still receive updates, of course, sa software lang na siya. Pero at the call of the times, may mga devices doon, Abi, na mas powerful pa kay mga phone, and then your phone cannot cope up with those changes. Ito yung magawan ta naka-signal ka iban nga phone. Like for example, mga 5G newer phones. Then you compared it when you bought your phone 5 years ago. The specifications of the phone is different from the newer ones. That is why you cannot compete with absorbing signal from the cell tower because it cannot compete with other devices. So sometimes it's just you need to have a newer devices so that you can compete with newer devices or some devices that using newer systems. Now, so much more, guys, for the advantages and disadvantages of MUM. Now, let's go to message queuing and trends. So, when you speak about message queuing, this allows the exchange of information between distributed applications. And the message queue can reside in the memory or the disk storage, whichever is most convenient. And that messages stay in the queue until such time they are processed by the service consumer. Though that the message queue and the application can be independently implemented, they do not need to know each other's position or continue to implement procedures to remove these trends for waiting to receive these messages. So you will notice, guys, that for example, in Facebook Messenger, that whatever messages that is being put in there and you didn't read it for such a time, then if you're going to update your phone or you put date or turn on your data or your Wi-Fi, and you'll be able to get signal from those from either of the two, then your messages will be updated. As time goes on, it will update lang gid. So kinahanglan mo mag-backread ka mga messages. Okay, those messages are not deleted, but it's still there, no, as the time continues. So that is an example of message queuing. Now, the drawback for this is you will notice your phone's batteries, mga battery ka phone ninyo, dali siya malobat. So because kung mas kinuha nyo ginagamit ang phone nyo, naga-consume na siya power. Kay syempre kung naga-message queuing ka mo, guys, naga-retain man da ka memory. And the retention of memory requires a lot of power and a lot of resources. On the trends naman, the first trend is Advanced Messaging Queuing Protocol. This provides an open standard application layer protocol for message-oriented middleware. So the second trend is the Object Managed Groups Data Distribution Systems, or the DDS. So it adds many feature standards to the basic DDS function. Another one is XMPP. This is the Communications Protocol for message-oriented middleware based on XML. Number 4 is Streaming or a Text-Oriented Messaging Protocol, also known as TTMP, and it is a simple text-based protocol that provides the interoperable wire format that allows some clients to talk with messenger broker supporting the protocol. And then the last one is the additional trends. See message-oriented middleware functions being implemented in the hardware. So this is usually FPGAs or other specialized silicon chips. For your activity 11, all you have to do is to use the messenger to send messages to your friends. Use it also to video call or chat them and produce a screenshot. So that will be your activity number 12, or what we call Messenger 111. Okay, so thank you guys for attending your class, and I hope to see you next meeting. So thank you and goodbye.